Please confirm me you can see the screen and my voice is audible without any background noise.
Audible, sir.
Okay, perfect. So we were discussing about how do we prepare the aldehydes and ketones, right? So let's see how can we do the preparation of aldehydes and ketones. Okay, so we can do by three methods. One is by oxidation of the alcohols. So we'll be oxidizing the alcohols by using different oxidizing agents. So that is one method. We will be doing by dehydrogenation of alcohols. So that is the second method. And we will be doing from hydrocarbons. So that is the third method we'll be doing. So we'll be showing all these three, how we gonna do. Okay. So first, the oxidation of alcohols. Okay. So what is meaning of oxidation?
Addition of oxygen,
Yes. Or else?
removal of hydrogen.
Okay. Okay. So see here, by oxidation of alcohols. When we talk about the oxidation of alcohols, there is a one thing we need to look into it. One is, are you taking the primary alcohols or are you taking the secondary alcohols? Okay, so that plays a very important role. If you take the primary alcohols, it will convert into the aldehydes. If you remember that we have discussed in the last class. So about the alcohol's properties, we saw the primary alcohols, they will be converted into the aldehydes. And the secondary alcohols, they will be converted into what? Come on. We have studied in alcohols chapter. Sharan, you tell me. Secondary alcohols will be converted into what if you do oxidation? Sharan, are you there?
Yes, sir.
Yeah, tell me. Secondary alcohols will be converted into what?
Ketone.
Ketones. Okay. Shrikar, tell me what happens with the tertiary alcohols?
Oh, what, sir?
What happens to the tertiary alcohols?
I don't know, sir.
Array, idiot. Revise the previous chapters.
Okay, sir.
Mandara, what happens to the tertiary alcohols?
So there will be no oxidation.
Yeah. So primary alcohols, they will be converted into the aldehydes if you are using the mild oxidizing agent. What happens if we use the strong oxidizing agent? Nitya?
So it converts into alkene.
It will convert into
Alkene.
or carboxylic acid. Nitya? If you take primary alcohols, if you use the strong oxidizing agent,
Primary alcohols will convert into carboxylic acid. I mistook it for 3-degree alcohols.
okay. So see here, so by oxidation of the alcohols. So for oxidizing the primary alcohols to aldehydes, you need a PCC. What is PCC? Pyridinium chlorochromate. Just remember, what is this PCC? It is a pyridinium chlorochromate. You don't need to remember the structure. If you want to remember, it is C5H5NH CrO3Cl minus. Okay, so we will be using the PCC, but remember just the structure is called as the PCC. Just know it. Okay, the chromium trioxide with chlorine and C5H5NH, that is a pyridinium chlorochromate. Okay, so just remember, for preparations of aldehydes by oxidation of the primary alcohol, we need an oxidizing agent. So what is the oxidizing agent that acts here? The pyridinium chlorochromate. Remember this. Okay. You need to know few things about this. Okay. First, what we are doing here, whatever the primary alcohol is there, you are converting into the aldehydes. Okay. You are doing the oxidation. Here O means you are doing the oxidation. So how does the reaction will go? It will go something like this. First, suppose R CH2OH with the help of the catalyst PCC. It will be converted into RCHO. And whatever the catalyst is there, it will be reduced. Okay. So there will be reduced PCC you will be seeing. That you don't need to know. Okay. So what it will do, the PCC will contribute the oxygen here. So this will be reduced. So just remember this. Okay. So the alcohols is converted into the aldehyde. Here the alcohol is a primary alcohol. Okay. And this is a aldehyde. And few things you need to know, just know it. Okay. So what is the PCC? It is a catalyst. Okay. So what this catalyst will do is it is electively oxidize the primary alcohols to aldehydes, but it will not further oxidize into the carboxylic acids. You should know this. Okay. So what it will do, it will only selectively oxidize. Why we call it as selectively oxidize? Because it will only oxidize the primary alcohols. And that primary alcohols, it will selectively oxidize to aldehydes. It will not convert into the carboxylic acids. So just remember this. So the further oxidation will not happen. Okay, so the further conversion into the carboxylic acids with the help of this oxidizing agent will not happen. Just remember this. It will not happen. Okay. So just a see here. I'll take an example. So you take a primary alcohol in the presence of the PCC. Apart from PCC, we need to take a solvent here. What is that solvent is CH2Cl2. Okay, so what we call CH2Cl2 as? What is the name for CH2Cl2? How many chlorines are there? Two chlorines are there. And what is this group? Alkane or alkene or alkyne? Arey yaar, answer. What is this? CH2 is a alkane or alkene or alkyne?
Alkane, sir.
Alkane. There is no double bond here.
Yes, I told
And
alkane.
okay, I heard it like in alkene. It's the
Alkane, sir.
alkane. Alkane. Okay, whatever. So see here, how many carbons are there here? Only single carbon is there. So why what we call it as dichloromethane. So just remember this. Okay, here the dichloromethane acts like a aprotic solvent. It acts like aprotic solvent, and this will be converted into the aldehyde. Okay. So why we are using this dichloromethane, the oxidizing agent? So just remember, it will prevent the further oxidation or over oxidation. So just know it will prevent over oxidation. So I told you, we have discussed in the alloalkanes, alloarenes. I think so. What is the use of the protic solvent, aprotic solvents? Remember, if not, just know it, aprotic solvent will prevent over oxidation. Okay. So understood. So how does this happen? By oxidation of alcohols in the presence of pyridinium chlorochromate, and this will selectively oxidize to aldehydes, but it will not further oxidize into carboxylic acids. And here the PCC is acting like a oxidizing agent. So this will oxidize and it will convert the product and it will be reduced. Okay, so that you should know. Here it will reduce it PCC. You will be finding. So why we call it as the reduced PCC? Because itself it will provide the oxygen to this alcohol and that alcohol will be oxidized to aldehyde. But as it provided, it has given the oxygen, so it is reduced form. So it will obtain the reduced form. Clear? Any doubts?
No, sir.
Is it clear for everyone? Confirm me.
Yes, sir.
Yes. Yes.
Nitya,
She's not there, sir.
what
She's
happened?
having a network issue. She might join again.
Okay, okay. Am I recording this?
Yes, sir.
Yes, sir.
Okay, okay, okay. So next one. So what happens to the secondary alcohols? Okay, so the secondary alcohols will be converted into the ketones. For that, we need an oxidizing agent, that is chromium trioxide. Okay, and this chromium trioxide will be happening in the aqueous solution. Okay, so just remember here, chromium trioxide in aqueous solution, this will be acting like a oxidizing agent. Okay, so the reaction will follow like this. So R2, as it is a secondary alcohol, so I am putting 2R, CHOH plus CrO3 in the presence of the water in aqueous solution. So this will be converted into the ketone R2, okay, C double bond O, or you can take it like R C double bond O R. You can take like that. Which is a ketone. So just remember, whatever RCOH R dash is there, it will oxidize. It will remove the hydrogen in the presence of CrO3 plus water, aqueous chromium trioxide. That will be converted into the ketone. Understood? So the secondary alcohol will convert into the ketone. So what you need to know here, first, it should be provided with the aqueous solution. Whatever the oxidizing agent we are using here, the chromium trioxide, it should be provided with the aqueous solution. Okay. And remember here, we saw that the PCC is a selective oxidizing agent. Yes or no? Because we know the PCC, if it is a strong oxidizing agent, what happened? The primary alcohols, they can convert into the aldehydes. They can further convert into the carboxylic acids. So that can happen with the primary alcohols easily. So that's why we should know, we should use a very selective oxidizing agent for primary alcohol. But here CrO3, it is not a selective oxidizing agent. Why? Because here the secondary alcohols will not further oxidize. Not easily. Okay, so that's why the secondary alcohols, even if it is you are using the strong oxidizing agent, it will still convert into ketones only. It will not further convert into carboxylic acids. Okay, so just remember, whatever the CrO3 you are using, it is a strong oxidizing agent which efficiently converts in the secondary alcohols to only the ketones. Just remember this. Clear?
Yes, sir.
Yes, sir.
So see here, secondary alcohols will convert into the ketones by using the oxidizing agent, which is CrO3, which is not a selective oxidizing agent. So next one, by dehydration of alcohols. So what is meaning of dehydration? Dehydration means we know it is the removal of the hydrogen. The reagent used is heated copper. Okay, so just know what is dehydrogenation. That is nothing but you are removal of the hydrogen. Okay, so you have to take away the hydrogen here, or you can say it is also kind of oxidation. And how does it happens? It happens in the presence of the heated copper. Okay, so the alcohol vapors are passed over this heavy metal catalyst. So whatever the copper you are using here, so that copper is exposed to the alcohol vapors. So when the alcohol vapors are exposed to this heavy metal catalyst, that is the heated copper, it will remove the hydrogens from the alcohols, and that will be converting it into the ketones. Remember, okay? For suppose, let's see an example here. So CH3, CS2, CS2, OH. So this will convert in the presence of copper and heat. You need to supply the temperature here. You need to heat the reaction. So that will be giving the product into CS3, CS2, C double bond OH. So it can be the aldehyde, or you take CH3, CH2, another CH3, OH. So what is this? This is a primary alcohol, if you see here. So this is a primary alcohol. And this is a secondary alcohol. So this secondary alcohol in the presence of copper exposed, okay? So this will be converting into CH3, C double bond O, CH3. So what you are seeing here? What are the products you got here? So first one, what is this? This is a primary alcohol. Yes or no? If you name this, what is this? It is a propanol, propane, one all, or you can say propanol, simply. And what is this? This is an aldehyde. Okay. And there are 3 carbons are there. So you can call it as propanol. Al means aldehyde. OL means alcohol. So the propanol is converted into the propanol in the presence of the heated copper. When you expose this primary alcohol into the heated copper, it is converted into an aldehyde. The same you do with the secondary alcohol, which is propane 2-ol. It is converted into propanone as it is a ketone. So this is called as propanone. What is the other name for propanone? Acetone. Remember this. Okay, so this is a ketone. This is a secondary alcohol. Understood? So this is the another way by dehydrogenation of alcohols. So what we are doing here, we are taking the heated copper, which acts like a catalyst, which is a heavy metal catalyst. So when you expose the alcohol, primary alcohol to the heated catalyst, it will convert into the aldehyde. If you do the same with the secondary alcohol, it will convert into the ketones. Here the catalysts are changed, but the reactants and products are same. The primary is turned into the aldehyde, the secondary is turned into the ketone. So don't remember it, don't forget. Next one, from hydrocarbons. So preparation from hydrocarbons itself can happen through 3 ways. One is the ozonolysis of alkenes. So one will happen with the help of ozonolysis of alkenes. The other one is by hydration of alkynes, and the other one is by alkaline hydrolysis of gem dihalides. Okay, so we'll be seeing how does these will happen. So first one, by ozonolysis of alkenes. Here you need to know one thing which is very, very important. One second. First of all, what you are doing here, you are doing the ozonolysis. That means in presence of ozone, lysis means the breakdown. Okay, so what is meaning of lysis? Breakdown. Ozone. You break down the ozone, and that will also break down the alkenes. Okay, so just know it is used for carbonyl compounds from alkenes. That means if you want to prepare the aldehydes or ketones with the help of ozonolysis. Okay, so just know ozonolysis it is a very, very powerful method for breaking down the carbon-carbon double bond. What is meaning of alkene? It contains the double bond. Yes or no? So this double
Yes.
bond you break down with the help of the ozone. Okay, you break down with the help of ozone. So that is what ozonolysis means. So that will be giving the carbonyl compounds. What are the two carbonyl compounds that it can give is aldehydes and ketones. So just remember what is meaning of ozonolysis. You are using the ozone to break down the double bond that is present in the alkene. So that will produce the carbonyl compounds which are aldehydes and ketones. Okay, so just know this mechanism, write down this mechanism. It will be very easy because if any questions comes, you can use this mechanism and you can process it. Okay, so just know the mechanism. It is very important. So what do we do here? I'll be showing the example. First, you just know what is the mechanism. How does the mechanism will happen? First one. So ozonolysis mechanism, it will happen through the oxidative cleavage reaction. Okay, so it will proceed by an oxidative cleavage reaction. Is Nitya present? Is Nitya there?
No, sir.
Okay. So here oxidative cleavage reaction will happen with the help of the ozone. Okay. So how does this will happen? So whatever the ozone is there, that ozone will attack the alkenes. So what happens here? The reaction starts with oxidative cleavage reaction. What is that means? The ozone will attack the alkene. And what cleavage it will do? It will break down the pi bond as well as sigma bond present between the alkenes. So we know what are alkenes? It is nothing but C double bond C. So one is the sigma bond, the other one is pi bond. So this ozone will break down the sigma bond as well as the pi bond. So that's what it will do. Okay. So what is the oxidative cleavage reaction means? It will break the pi bond and sigma bond between the carbon-carbon. Okay. So when you do that, there is an intermediate will be formed. So that intermediate is called as the ozonide. So intermediate, the ozonide will be formed. So once the ozonide is formed, with the help of zinc test, so we will be doing the fourth one. So what we will be doing here? So we will use the zinc test. We will use the zinc test to reduce the ozonoid. So whatever the ozonoid that is formed, with the help of zinc test, we will be reducing it. And final, so finally, the carbonyl compounds are formed. So these carbonyl compounds can be aldehydes, or it could be the ketones. Here it could be or it could be and as well. That means both aldehydes and ketones are formed, or only aldehydes are formed, or only ketones are formed. Okay, so know this. So how does this? So what is this ozonolysis? Ozonolysis, it will, with the help of ozone, we will be breaking the double bond in the alkene. Okay, so when you do that, it will form the aldehydes and ketones, which are carbonyl compounds. So how does this reaction will happen? First, whatever the ozone is there, it will attack the alkene. So when it attacks the alkene, it will form the oxidative cleavage reaction. What is that means? The carbon and carbon contains the double bond. One is the pi bond, the other one is sigma bond. So here the ozone, when it attacks this double bond, it will break both the sigma and pi bonds. So when you do that, there is a formation of the ozonoid will happen, which is an intermediate. Now, with the help of zinc test, whatever the ozonoid is there, it will further reduce to form the carbonyl compounds, which are aldehydes and ketones. Understood?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So just know this. So you can see here. So here, this is the, I mean, it depends. Whatever the aldehyde or ketone, it depends on what substituent you have taken here. What substrate you have taken here, that will form the ketone, or it will form the aldehyde, or it will form both the aldehydes and ketones. Just know it. So, but intermediate, there is a ozonoid is present. Okay. So these are the reactants, there is intermediate, and there is a final product, which are carbonyl compounds. So just know this one. So just draw with me. So first you take an alkene. So let's take an alkene. So this is an alkene. In the presence of O3, the zinc and water, it will be like this. Now we know there is a ozone, which is O double bond O, O. This is the ozone, O3. So if you see here, there is a pair of electrons are present here. There is a only single pair electrons present here. And here, there is a 6 lone pair are present. Okay. So what it will do, so whatever this lone pair, which it is having the excess lone pair, it will try to attack the carbon which is present here. And here here only 2 lone pairs are present. So it will try to take the electrons from this carbon. So that is how the ozone attack will happen. So when that reaction happen, it will give like this. So whatever this is there, it will form. But whatever the ozones are there, they will be forming the structure here. So as it is attacked, it will try to form the bond here. So there's a bond, and there is a bond here, and there is a bond here, which will be here. Because this ozone is trying to attack this one. So the bond will be formed like this. Okay? Understood how this has happened?
Yes, sir.
Yes, sir.
Okay. So this intermediate structure, we call it as the ozonoid. So this ozonoid will further break into the aldehydes or ketones. So let's say ketone, and there is a aldehyde as well. And there is a zinc oxide, ZnO. Okay. So if you see here, where does the bond breakage has happened? At the double bond. Yes or no? The bond breakage has happened at the double bond. So you see this structure. So this has converted like this. So which gave the ketone. And you see this structure. You see this structure now. So this has converted into this. So whatever this is there, it has converted into the aldehyde. Okay, so this is the ketone and this is the aldehyde. And this is the intermediate, which is ozonide. Understood?
Yes, sir.
So this is an alkene. This is a ozonide, aldehyde, ketone, and ZnO. So whatever the substituent that we take here, it depends on that. Okay, so based on this substituent, it will decide whether it will be aldehyde or ketone, or only aldehyde or only ketone, or only or both. So that will depend on the whatever the substituent that we are taking here. 1 second, guys. I need to put charging. So let's see another example for better understanding. So let's take another alkene. Okay, so here the double bond is present here. You understood? I'm not mentioning the carbon, so you can understand or not? Or should I mention the carbons here? I'm drawing a concise structure. You can understand, right?
Yes, sir.
So what is
Yes.
the name of this compound? What is the name of this compound? So the parent chain is having 6 carbon. So what we call X. On the second carbon, there is a double bond is present, 2 in. But if you see on the second and fourth carbon, there are 2 methyls are present. So 2 comma 4 dimethyl X2N. Understood? So 2 comma 4 dimethyl X2N. I'm just telling it, okay? You don't need to know that. So why I'm telling is they can give any type of alkenes. Based on that, you should be able to tell whether it will form the ketone or whether it will form the aldehyde, or it can form both based on this structure. Okay. So we know in the presence of the ozone 3 and zinc and water. So what it will do, this ozone will try to attack the double bond. Okay. So when it break the double bond, just you know this, in presence of this double bond, so the compound will be split into the left part and the right part. Okay. So you see this left part, the left part will give like this. And you see the right part, whatever this part is there, that will be something like this. Just know wherever the double bond is broken, just you put there itself the double bond and you put the oxygen. That's it. So see here, for suppose I removed this carbon and I kept the oxygen here. So that came this. And I have taken all this and whatever the double bond is there, I attached oxygen. So this is the ketone and this is the aldehyde. You understood? So before I explain how the ozone will attach and how the ozonoid will form and how the ketone and aldehyde is formed. But you don't need to know all that. Just know the ozonoid. In order to know that what is this ozonoid, I explained. Okay, but you don't need to draw all the structure. Just know how does the final ketone and aldehydes will form. Just know that much. Understood? So just remember always the split will happen at the double bond. Okay. So wherever the double bond is there, the split will happen there. Okay. And that will result in formation of the carbonyl compounds. It can be the aldehydes and it can be the ketones. Is that clear?
Yes, sir.
Yes, sir.
One second. One second, guys. Okay, just know these things. A quick revise of the points that we saw. So ozonolysis mechanism proceeds via oxidative cleavage reaction. Yes or no? We saw this. Next one. The ozone not only breaks the carbon pi bond, but also the carbon-carbon sigma bond. And that's how we saw. So it will break the pi bond and it will form the aldehyde. It will break the sigma bond and it will form. Okay. So that's how it will try to make the ozonide structure. Next one. It involves the attack of ozone on the given reactant to form the ozonide. We saw that's an intermediate. The eliminate of the oxygen in this intermediate with the help of the zinc test result in formation of the final product, which is nothing but the aldehydes and ketones. You understood? What are the 5 points that are given here?
Yes, sir.
If you don't understand these points, just know these points. Okay, you might have understood this mechanism now, so just follow this mechanism. So next one. So tell me, what is the answer? So ozonolysis of an organic compound A produce acetone and butanone in an equimolar mixture. Identify A from the following compounds. So what he is asking, he has given us the products, but he is asking us what will be the substituent. Okay, so just let's see the substituent. What he is said, it's acetone and butanone. What is acetone? This is the acetone. Yes or no? Or else you can remember like this. This is an acetone. So C, double bond. This is an acetone. And the other one is butanone. Okay. So butanone, you can. So actually you change this. It is a buta 2 no 2 on. Okay. It should be buta 2 on. This is butane 2 on. And this is acetone. And we know the cleavage will happen at the double bond. Okay. That means whatever this structure is there, it is the common structure. And whatever this structure is there, you need to put it here. Understood? So just know this. For suppose it will be like this. So C, double bond. I'm removing the oxygen. And whatever the blue structure is there, this is the blue structure. You add it here. Okay. So that will be something like this. In the presence of O3, Zn, H2O. So what is this structure now called? See here. Take the longest chain. So 1, 2, 3, 4, 5. So pent. On the second carbon, there is a double bond is present. Okay. And there is a methyl group is present here. This is one methyl group. Let's say this is CS3 and this is CS3. So you can call this as 2, 3 dimethyl, because this is the second carbon, and third carbon which contains dimethyl. And how many? 5 carbons are there. So penta. And there is a double bond here, 2 in. Understood? Rashikar,
Yes, sir.
అర్థమైందా?
Yes, sir.
కొంచెం కన్ఫ్యూజన్ గా ఉందా?
A little bit confusing.
Okay. What about the others?
Understood, sir.
Understood, sir.
Okay. Next one. So by hydration of alkynes. So what is this hydration of alkynes? Addition of water to ethine in the presence of H2SO4 and HgSO4. What is this HgSO4? Just remember HgSO4 means it's a mercury 3 sulfate. Sorry, it's not 3, it's a 2 sulfate, which acts like a catalyst. So gives the acetaldehyde, all other alkynes gives the ketones. Okay, so just know here, so what's happening? You are adding the water. Okay, so why we are doing that? So why we are adding the water here? To break down the carbon-carbon triple bond. Okay, so the water is added in order to break down the carbon-carbon triple bond. What is meaning of ethine? Ethine means the carbon and carbon attached with triple bond. So this is the first alkyne, right? For suppose you take single carbon, you don't find alkyne group, but you take the double bond, I mean 2 carbons, you can find the first alkyne. You take 3 carbons, you can find alkyne. So only this first alkyne, only the first alkyne, that is ethine, will only show the acetaldehyde. But you take any other alkynes, like when n is equals to 3 or n is equals to 4 or n is equals to 5, that means those number of carbons, they all will form the ketones. Only the n is equals to 2, that is the first alkyne which is formed, it will only show the acetaldehyde, but all the others will form the ketones. Just know this. Okay, so only C triple bond C will form the aldehyde, but remaining all the others will form the ketones. Just know this. Is that clear?
Yes, sir.
Yes, sir.
So does this reaction will happen is, this reaction will happen like this. So CH triple bond CH, with the help of water, this water will break the triple bond. Okay, so this will happen in the presence of HgSO4, that is mercury sulfate, which acts like a catalyst. And there is a sulfuric acid as well, H2SO4. So that will be giving an intermediate molecule, which is alcohol. Okay, so just remember, it will form an intermediate molecule. Can you name what is this molecule? What is this molecule? You can call it as enediol because there are 2 alcohols are there, and it is ethane. Ethane 2-diol. Okay, or you can say 1, 2. Just remember the normal naming, it is called as enol. Just know this. Okay, because it's an alcohol. You can see here the alkene attached with OH. So this is an alcohol. So this will further undergo a thing called the tautomerization. What is tautomerization? Tell me. Your Saurabh sir has told, I think. What is tautomerization? So what is this compound? At least tell me this. What is this compound? Come on, guys, answer. So what is this? I told you here. When n is equals to 2, the ethine will give the aldehydes, but n is equal to 3 or 4 or 5. All these will produce the ketones. Leave about that. What is this? COH, or you can say CHO. CHO is a aldehyde. You're not understanding, or you feel bored? Mandara,
Yes, sir.
what happened?
Sir, I
You,
got.
you got it?
Yes, sir, I'm getting it.
Then why you didn't answer?
Like I was thinking.
Shrikar,
Yes, sir.
ఎరా నీకేం అర్థం కాలేదా?
Sir, I left the meeting, sir. I just joined now only back.
Sharan, what about you?
Sir, understand this.
So just remember, what is tautomerization? So reaction, okay, I'll explain you what is tautomerization. Okay, there's no place. I'll write here. So just know what is tautomerization. Okay, so it is the rapid interconversion between two or more isomers, structural isomers. They are called as tautomers. Okay, and happening of these tautomers is called as tautomerization. So what is tautomerization? It is the rapid interconversion between two or more substituents, or you can say two or more structural isomers. We call it as tautomers. Okay. So what is tautomers? So just know tautomers means same molecular formula, but structure is different. So we call it as tautomers. So suppose you see here, okay. So actually the position of atoms or bonds you can say, okay. So suppose you see here, both are same structure here. The alcohol which is present here and the aldehyde which is present here, both are same structure. I'm sorry, both are same chemical formula. If you count the number of carbons, number of hydrogens, number of OH, all are same. But what happened? The structures have changed up. Okay. You can same molecular formula, but differ in position of, you can say the position of atoms. Otherwise, this would have become isomers. Okay. But there is a slight difference between isomers and tautomers. Differ in atoms or bonds. You can say bonds. For suppose here the double bond is present between the carbon and carbon, but here the double bond is present between the carbon and oxygen. Here it is OH, but you don't find any OH here. Here methyl group is present. So if you count the number of carbons and all, they will be somewhat same. So just understand, there will be tautomerization will happen and that result in formation of another structure here. So the addition of water to ethane in the presence of sulfuric acid and HgSO4 gives the acetaldehyde only if the N is equals to 2. That means only 2 carbons. That will give the acetaldehyde. But you take the 3 carbons, 4 carbons, 5 carbons, all they will give the ketones. Just know. Remaining all the other alkynes will give ketones, but only the 2 carbon alkyne will give the aldehyde. So next one. So terminal gem dihalides to aldehydes. So what are gem dihalides? So what is this? The preparation of aldehydes or ketones from the terminal geminal dihalides. Okay. So what is gem dihalides? Gem dihalides means it's a geminal dihalides. What is meaning of geminal dihalides? Just know this. Okay. So compounds where two halogens attached to same carbon. So we call it as the geminal halides. Okay. So what is meaning of geminal dihalides? When a carbon is attached with two halogens, the same carbon is attached with two halogens, we call it as geminal dihalides. Okay. So see here, how does the conversion will happen? So this will happen like this. So it is a geminal dihalide because two chlorines are there. So this will become a gem dihalide. Okay. So this will convert in the presence of aqueous potassium hydroxide into an alcohol. And this will further, by removing the water molecule, it will convert into an aldehyde. Okay, so this step will be having three things. What is that? First one is nucleophilic substitution. So first, I'm not explaining in detail the mechanism. So the first thing what it will happen is nucleophilic substitution. You guys know what is nucleophilic substitution, so I'll not explain it. So there will be nucleophilic substitution will happen, and this nucleophilic substitution result in formation of an alcohol. Okay, so that is nothing but the geminal dihal. Again, geminal means when carbon attached with two alcohols. So geminal dihal formation will happen. So formation of geminal dihal. So once this geminal dihal is formed, from that you are removing the water molecule in order to form the aldehyde. So there will be dehydration will happen. So there is dehydration. Okay, so it is taking place in three ways. One is the nucleophilic substitution, which is result in formation of the geminal diol that happens with the help of aqueous potassium hydroxide. And to remove the water from this geminal diol, you will be getting the aldehyde. Okay, so by dehydration. Understood? So just know what are the geminal dihalides. These are the compounds where two halogen atoms attach to the same carbon. Okay, and this is called as the alkaline hydrolysis. Okay, so why we call this as alkaline hydrolysis? For suppose you see here, that's a potassium hydroxide, which is a strong base. So this is a strong base, and the strong base, I mean the base is called as the alkaline. We know acidic and alkaline. So here it is a base, so we call it as alkaline. And there is hydrolysis is happening. So alkaline hydrolysis. Okay, so what is alkaline hydrolysis? A strong base, which is a potassium hydroxide, is helpful to break the bonds in the molecules. Okay, so that's a breaking the chlorine and chlorine, so that the alcohol the group will attach, the hydroxyl groups will attach, and you remove the water, that will result in formation of the aldehyde. Understood?
Yes, sir.
Yes, sir.
Yes, sir.
And one more thing you should remember, it's a terminal gem dihalides. Okay, it's a terminal geminal dihalides. So how does this will happen with the non-terminal geminal dihalides? Okay, so the same will happen. First, you will be doing the you will be breaking with the help of potassium hydroxide, so that result in formation of the alcohols, and that alcohols will further converted into ketones. That's the difference. For suppose here, with the help of terminal geminal dihalides, you will be having the aldehydes. Okay. Whereas if you take the non-terminal, what is meaning of terminal and non-terminal? For suppose if you see the halides, they are attached to the carbon, which is the end carbon. It could be the first carbon or it could be the last carbon. Okay, it is not like either it could be one or last, but it is not the intermediate like 2, 3, 4 or something like that. Okay. Whereas non-terminal, it is an intermediate one. For suppose you see the example R, C, R dash. So this carbon is having two different halogens, chlorine and chlorine. In the presence of aqueous KOH, it will turn out to be the alcohol, which is R, C, R dash. It contains OH and OH. This will remove the water, hydrolysis will happen and result in formation of ketone. Understood? So if you see here, the carbon is not the first carbon or last carbon. It is the between carbon. It is not a terminal carbon. Terminal means what? End. It could be the first or last. Whereas here, it is the intermediate carbon, not the first or last. So that's a non-terminal and a geminal dihalide because the same carbon attached with two chlorines. So that will turn out to be ketone. So just remember, if it is an end carbon, it will form the aldehyde. If it is a middle carbon, it will form the ketones. Understood? So the same process again, it will happen here. Okay. So what happened? The geminal dihalide, which is a non-terminal, it reacts with the aqueous potassium hydroxide. Okay. So what does the aqueous potassium hydroxide will do? It is containing the hydroxyl group. So this hydroxyl group will replace the chlorines. So whatever the OH is there, that will replace the chlorine. So all the chlorines will be replaced with the OH. That is forming the geminal diol. So just know this is the geminal diol. Whereas this one, geminal dihalide. Okay. Next one, this geminal diol will undergo dehydration. That means you will be losing the water here and result in formation of the ketone. So how does the water will be removed? So there is a two hydroxyl groups are there. From one hydroxyl group, hydrogen will be removed. So suppose here, the hydrogen will be removed. From the other hydroxyl group, both the OH will be removed. Complete OH will be removed. So this OH and this hydrogen will be removed like a water molecule, which will be result in formation of the ketone. Understood? Just you should know this. This is very, very important. Whether you are taking the non-terminal or terminal. If it is terminal, it will form the aldehyde. If it is non-terminal, it will form the ketone. So see here, tell me this. Is it a terminal or non-terminal? Okay. Actually, this is a different example. Sorry. This is not a halides. So what is this? This is an alkyne. So what happens with the alkyne when it reacts with water in the presence of HgSO4 and H2SO4? We saw tautomerization. I told you now. First, it will form the alcohol and then it will form the ketone or aldehyde. Okay, either it will form the aldehyde or ketone. So see here, this will result in formation of carbon CH2 and there's a double bond, there's a OH and there's a CH3. So this will undergo tautomerization and result in formation of, so whatever the double bond is there, it will break and it will form the single bond. So which result in formation of the ketone. Okay, so just remember, whenever you add the water for an asymmetric alkene, so which type of alkene is this? It is an asymmetric alkene. That means, what is meaning of asymmetric? On either side of the triple bond, if same number of carbons are present, then we call it as symmetric. For suppose C, C, triple bond C, C. So this is a symmetric. And this one like this. So this is an asymmetric. For suppose on the left side of the triple bond, one carbon is present. On the right side, two carbons are present. So this will become asymmetric. Okay. So for the asymmetric alkyne, in the acidic condition, for suppose you are using the sulfuric acid. Okay. So acidic hydrogens will attach to the carbons which are having greater number of hydrogens. So which carbon is having greater number of hydrogens here? So out of this carbon and this carbon, which one is having more hydrogens? So this one is having more hydrogens. Yes or no? So the hydrogen will go and attach here. Whereas the OH group that will attach to the carbon which are having less number of hydrogens. Okay. For suppose you see here, the carbon on either side which are having the double bond. Sorry, triple bond. So this is one carbon and this is the another carbon. Don't forget about this carbon. Don't think about this carbon. Just think only these two carbons which are having triple bond. The carbon which is having more number of hydrogens, it will be adding up with more number of hydrogens. So this will get the hydrogens. Whereas the carbon which is having less number of hydrogens, that will get the hydroxyl group. So that's how you can see here. So this has turned out to be CH2. So whatever the triple bond is there, it has become the double bond. And whatever this carbon is there, it is attached to the OH. So that's how it formed an intermediate molecule, which is an alcohol. Okay. And this will undergo tautomerization and result in formation of ketone. Understood? If something example comes like this, so which one should attach with OH, which one should attach with hydrogen? You be careful. Okay.
Yes.
So next one. Do you remember this example? So what happens when you treat with ozone? It will form ketone and aldehydes, or it will form only the ketones, or it will form only the aldehydes. Okay. So in this condition, if you see here, so what happens? We know the ozone will go and attack the double bond. Okay. And it will try to cleavage and O will attach to that. Yes or no? So this will be like this. CH3. Wherever the double bond is there, O will attach. And you take the right side one. It will be like this. CH3, CH3. And whatever the double bond is there, O is present. If you see here, the product that is formed from here, they both are ketones. Understood? So how does they form? See, if you don't understand the concept and if you try to mug up, this will become impossible. You cannot even remember what this will convert into what. See the logic. The ozone will break the double bond. So it will attack here. And there oxygen will attach. So oxygen is attached. And on this right side also, I am attaching the oxygen. Very simple. And if I see the end product, it is somewhat like RCR double bond O, which is nothing but a ketone. Very simple. But if you try to mug up, you will never understand. You cannot answer anytime. Okay. So next one. I told you this. So what happened? This is a primary alcohol. The primary alcohols. Is it a primary alcohol or is it a secondary alcohol? Tell me. Come on,
Primary.
guys. Huh?
Primary.
See here. This is the carbon. Here is a carbon. Here is a carbon. So this will be secondary carbon or primary carbon? Secondary carbon. And secondary carbon, OH is attached. So this is a secondary alcohol. So secondary alcohol will form aldehyde or ketone. Sharon, you tell me this. Secondary alcohol will form the aldehyde or ketone?
Ketones.
So this will form ketone. Now tell me this. What will be the answer? So what happens in the presence of Hg, 2 plus and H plus?
So is it C?
Nope. So first of all, tell me what is this reaction? So it comes under which reaction? Tell me. Where do we saw Hg and H plus?
By hydration of alkynes.
By hydration of alkynes, right? So there we use the mercury sulfate, which is HgSO4, and we use the sulfuric acid, H2SO4. I told you the sulfuric acid will provide the acidic hydrogens here. And there it will form an intermediate product, which is nothing but an alcohol. And then it will finally form into an aldehyde. Yes or no?
Yes.
So tell me, which one is the answer here?
So A.
Sir,
Mm-mm-mm.
B.
Oh,
Hello? So tell me, which one here? One second,
is
guys.
it B?
Nope.
Sir, is
not
it
B.
A? Like, I'm not sure, but then just a guess.
Yes. So see here how it will happen. So in the presence of this, for suppose it's given this way. So pH, which is nothing but a phenol group. Okay. C triple bond C and then CH3. So in the presence of mercury sulfate and sulfuric acid, they will provide Hg plus 2 and H plus. So just remember, if they mention only Hg plus means you don't think that I don't know this reaction. It's nothing but HgSO4. And here H plus means nothing but H2SO4. So sometimes they can also give tricky this way. They will just give what is the use of the catalyst. One catalyst will supply the Hg plus 2. So that's why they gave like this. The other one will supply the H plus. So instead of giving sulfuric acid, they simply gave H plus. It will be converted into, so whatever the pH is there, the pH will be there, the carbon will be there, and whatever the triple bond is there, it will form into the double bond and the carbon and then CH3. Okay. I told you, so where does the hydrogen will attach? Where does the OH will attach? So tell me, where does the hydrogen will attach and where does the OH will attach? The carbon which is having less number of hydrogens, the OH will attach, yes or no?
Yes, sir.
But in this condition, you don't have something like that. Okay, here also same number, here also same number. In that condition, what we need to take is the one which is having the bigger one will have the OH. Okay, I mean here it is a phenol group. So this in this position, the alcohol will attach. Okay, and hydrogen will come and attach here. Now this will further convert into the pH C, and whatever the double bond is there, it will further break into single bond. So how does that will happen? That will happen by the tautomerization. I told you, tautomerization means what there is internal shuffling will happen. So whatever the hydrogen is there, it will go and attach here. Actually, this hydrogen will go and attach to this carbon. Okay, so that will form like this. So this carbon will be getting good number of hydrogens, and whatever the double bond is, for suppose this is CH, right? So this will be converted into the CH2. And now this carbon doesn't have the, suppose here it is a C, but here it should be the CH2, but it is not like that. So it should manage the double bond. How it will manage the double bond? It will make the double bond with oxygen. Now, if you see, the carbon is having all the 4 bonds. So whatever the bond you try to break here, then this carbon is only got the 3 bonds. Yes or no? This is somewhat like this. It got the 3 bonds. Now it has to manage the 4 bonds, and here the oxygen has to manage the negative charge. So that will be managed by making the double bond here. And now pH, C double bond O, CH2, CH3. So which will be the answer here? This will be the answer. Understood?
Yes, sir.
Yes, sir.
So that's it for today. We'll stop here. I'll upload this in YouTube. If you want, once again, watch it. If you miss it somewhere else, any point. And please read. Revise the concepts. If you don't revise the concepts, everything will be vanished.